Hello everyone. So today we are going to continue the topic that we started in last video. The topic name is, we know that it is a solution. We started in the last video. So today we are going to continue this solution part. So today we are going to take about that is concentration terms. Concentration terms. So first we'll understand what are the uses of concentration terms. ಯಾವುದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಟರ್ಮ್ಸ್ ಯೂಸ್ ಏನು ಅದರ ಬಗ್ಗೆ ಮಾತಾಡ್ಕೊಂಡು ನೆಕ್ಸ್ಟ್ ಹೌ ಮೆನಿ ಟೈಪ್ಸ್ ಆಫ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಟರ್ಮ್ಸ್ ಆರ್ ದೇರ್, ಸೊ ಹೌ ಟು ರಿಪ್ರೆಸೆಂಟ್ ದೋಸ್ ಆಲ್ ಥಿಂಗ್ಸ್. ಸೊ ಫಸ್ಟ್ ವಿಲ್ ಡಿಸ್ಕಸ್ ಅಬೌಟ್ ವಾಟ್ ಈಸ್ ಯೂಸ್. It is used to represent the amount of solute present in solution. So how much amount of solute is there in particular solution, that idea will be given by the concentration terms. See, we can find out this concentration in two ways. One is qualitatively we can find it out, and we can find it out by quantitatively also. Quantitatively also we can find it out. So how how can we find concentration qualitatively means? So have you heard about so in lower grade standards we will learn about this kind of words we will be hearing that one. For example, dilute NaOH or dilute solution, or we'll call it again one more word you may be heard, that is concentrated solution. So what is the meaning of this one? So dilute solution means what we'll say. So dilute solution means, so we'll say if solute is less in solution, then it is called as a dilute solution. If I am talking about concentration solution means what? Concentrated solution means if solute is more in solution, then it is called as what? It is called as a concentrated solution. But these terms or these will create some confusions. Why it will create some confusions means, so these, when I can use this dilute solution or concentrated solution means when we are comparing the solutions, so then only we can use this one. But quantitatively it is important to mention how much concentrated it is or how much dilute solution it is. So that one we will discuss in quantitative concentration terms. So that is the importance. So it is very important. Quantitatively we have some concentration terms na determine ಮಾಡಬೇಕು quantitative ಆಗಿ. So simple for example dilute solution ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ how much dilute it is means how much solute particle it is having. So it will create some confusion. So that's why, so quantitatively we have to mention how much concentrated solution it is. So that's why it is important. So now let me start with some concentration terms. That is, first one, weight percentage, or simply we can call it as a mass percentage. So mass percentage, so this one. So what is mass percentage? So W by W percentage, it is equal to amount of solute present in total amount of solution into 100. If I do means I'll get what? I'll get W by W percentage or mass percentage. So in question how they will give means, they will give simply 10% NaCl, 10% NaCl in water, 10% NaCl in water if they given, or they will also give like this also, 10% by mass NaCl in water. Okay, so like this statements will face while doing the questions. So then So what is the meaning of this one? 10% NaCl in water or 10% by mass NaCl in water means, it means that 10 gram of NaCl, 10 gram of NaCl salt present in 100 gram of solution, 100 gram of solution, or we can say like this also, 10 gram of NaCl present in 90 gram of water. See, here water is a solvent. Okay, keep it in mind. Water is a solvent. So 100 gram of solution means total amount of solution is how much? 100 gram. But if I am talking about only solvent means that is 90 gram. So let me elaborate in detail. Suppose 10% by mass NaCl they are taking now. So here, so what is weight of NaCl? It is 10 gram. What is weight of total weight of solution, salt solution? 100 gram. We can find out weight of solvent now easily. Weight of solvent, that is water. We can find it out now. So that is equal to weight of solution minus weight of solute. If I do means what I'll get. So it is equal to weight of solution is how much? 100 gram minus weight of solute is how much? It is 10 gram. It is equal to 90 grams. So this is the W by W percentage or mass percentage. And one more point, that is note point, that is, so this percentage W by W not depend upon temperature. Temperature ಮೇಲೆ depend ಆಗಿರಲ್ಲ. Why it is not going to depend upon temperature? See, if I am increasing temperature, here we are taking in gram now, like it will not depend upon temperature. If any gas is there or if any liquid is there, if I am taking in volume, then only it will depend upon temperature. So weight will not depend upon temperature, no? So weight never depend upon temperature. If I am increasing temperature, weight will be remain same only. If I am decreasing temperature, weight will be remaining same only. But if I am having any liquid, if I am taking in volume, then if I am increasing temperature, volume will increase. So then in case that one, it will depend upon temperature. But W by W percentage not depend upon temperature. Very, very important point this one. So next, coming to the second term, second concentration term, that is volume by volume percentage, or simply we can call it as so that is volume percentage. Volume percentage. Okay. So what is this one? So in the place of weight, amount of solute I said na, here percentage volume by volume, it is equals to volume of solute by volume of solution into 100. So this is only called as volume by volume solution or volume by volume percentage. So for example, I am having this one. So here they will write, they will mention on the bottle, that is reagent bottle, they will mention like this: 25% by volume of ethanol solution. If they mention like this, what is the meaning of this one? 25 ml of ethanol present in 100 ml solution. 100 ml solution. Okay, so that is only called as volume by volume. And now you say that whether the volume by volume percentage depend upon temperature or not. Yes, of course, here volume is there, na? Here also volume is there, here also volume is there. It will depend upon temperature. So as temperature increases, volume also increases. So that's why it is also depend upon temperature. This term, this concentration term depend upon temperature. So this is second term. So next one more term will be there, that is weight by volume percentage. Weight by volume percentage. Here one is in gram will take, one more that will take in volume, that is in ml will take. So W by volume percentage, it is equals to amount of solute present in total volume of solution. into 100. So this is only called as W by volume percentage. For example, they will say like 20 gram, so like we'll take glucose, 20 gram glucose percentage W by V is present in water. Now what is the meaning of this one? So this means that 20% you do, not 20 gram, 20% W by V glucose is present in water means what? Here 20 gram of glucose present in 100 ml of solution, 100 ml of solution. Now can you say that, like, can we find out how much weight of solvent is there here? See, we can't find here because one term is in volume, one term is in gram. So here we are taking here gram, here we are taking in ml. So directly we can't find the volume of weight amount of solvent here. So what we done in, if W by W percentage is there means, then what we can do, if I want to know about amount of solvent, what I did like this, it is equal to amount of solution minus amount of solute now. But now this time I don't know, that is amount of solution I don't know, this is I don't know. So that's why, so first if I want to find out amount of solvent, if I want to know, then I want to know density also, density of solution also I want to know. For example, consider that if density they given, density of solution they given, that is how much, like 1.0 gram per centimeter cube they given. Okay, so this is density of solution they given here. Now, so now what I given there, that is 20 gram glucose is there, that is solute is there. Next, volume of solution is how much? Volume of solution we know that is 100 ml. Now density also know, density of solution is how much? Density of solution is 1 gram per ml, also you can take, centimeter cube also you can take, density we know. So now what is the formula of density? Density is equals to mass by volume. So I want to know mass of solution is equals to what? Density into volume only now. So it is equal to 100 only now, 100 gram only now. Mass of solution is 100 gram. So now I got to know mass of solution. So now we can find mass of solvent is how much now? Mass of solvent is equals to mass of solution minus mass of solute. So mass of solution is how much? 100 minus mass of solute is how much? It is now 20 gram. So it is equal to 80 gram of solvent is there. Like this we have to find. We can't find directly. We have to know the question. In question they should give the density of the solution, then only we can find this one. Yes or no? So I hope that you are understanding these all concepts. So very simple topics. So like this we can represent the concentration of solute in particular solution. So still we have, that is next we will take next concentration term, that is mole fraction. We are having mole fraction. It is represented by this chi. So mole fraction is what? Suppose I am having, assume that like I am having one mixture. So A plus B, it is there in this one, two solute I am having, or like two components I am having, A component and B component. Now I want to find the composition of A only. Composition of A only I want to find means, then mole fraction of A is equals to number of moles of A by total number of moles of A plus total number of moles of B. So this is only called as mole fraction. So here this is, for example, mole fraction of B is what? Number of moles of B, then number of moles of A plus number of moles of B. So this is only mole fraction of this B particle or B component. So now if I am checking mole fraction of A plus mole fraction of B, it is equal to, always equal to 1. remember. So this is only called as mole fraction. So we have to find number of moles of A, number of moles of B, we want to know, then only we can find mole fraction of A. Means each composition we can calculate by if any mixture is there. So then we are going to use this kind of the concentration term. So in this video we'll end here only. So remaining part will continue in next class. Thank you.